Hey everybody, welcome to my fourth video on exponents, and in this video I want to go over a more complicated example and talk about properties of exponents some more. And notice how in this example how we have a bunch of stuff being multiplied inside of the parentheses. Notice how we have a 5 being multiplied by x being multiplied by y inside the parentheses, and we have this exponent of 2 outside of the parentheses. And whenever you see a problem like this, you can use a property very similar to the power rule to get rid of the parentheses. You can take this outside exponent of 2 and you can multiply it by every exponent inside of the parentheses. So let me show you what I mean by this. This outside exponent of 2 can be multiplied with the exponent on top of the 5, which you don't see, so you can assume that it's an exponent of 1. So this 5 can be rewritten, and you need to multiply the exponents. So this exponent of 1 is multiplied with the exponent of 2. 1 times 2 is equal to 2. So now let's do the same thing with the x term. This outside exponent of 2 can be multiplied with the exponent on top of the x, which you don't see, so you can assume that it's a 1. So the 1 exponent can be multiplied with the outside exponent of 2. 1 times 2 is also equal to 2. So now we'll do the same thing with our y term. We can take this outside exponent of 2 and multiply it with the exponent of negative 2, and 2 times negative 2 is equal to negative 4. So now we have successfully gotten rid of our parentheses in blue, and this is being multiplied by the parentheses in red. So let's do the same thing for our set of red parentheses. So notice how we have a outside exponent of negative 2, and we need to multiply that by all the exponents inside the parentheses. So if we take negative 2 and we multiply it by the exponent on top of the 2, which you don't see, so you can assume it's a 1, so that becomes a 2, and if you multiply the exponents, you have 1 times negative 2, which is equal to negative 2. Now let's do the same thing with our x term. The negative 2 can be multiplied with the exponent on top of the x, which you don't see, so you can assume it's a 1. 2 times negative 2, times positive 1 is equal to negative 2. Let's do the same thing with our y term. Multiply the negative 2 with the exponent on top of the y, which you don't see, so you can assume it's a 1. 1 times negative 2 is equal to negative 2. So now we have successfully gotten rid of all of the parentheses in our expression, and now we have a bunch of stuff being multiplied with each other. And whenever you're multiplying, the order in which you multiply does not matter. So I'm going to rearrange this and multiply all of the constants first. And notice in blue we have a constant of 5 squared, so I'll put that in the front. And in red we also have a 2 with a negative 2, which is also a constant, so I'll put that constant in the front as well. And the next thing I'm going to do is put all of the x terms together. Notice in blue how we have an x squared term, so I'll put that next. And in red we have a x with a negative 2 exponent, so I'll put that with all of the x terms. And now I'm going to put all of the y terms together. In blue we have a y with a negative 4 exponent, so I'll put that one first. And that's going to be multiplied with our other y term, which is in red, which is y with a negative 2 exponent, so I'll put that one second. So now we have rearranged the order in which we multiply, so now the constants are together, the x terms are together, and the y terms are together. And before we move on to the next step, I want to scroll down just so I have a little bit more space to work. So now let's simplify this even further. Notice how we have two x's being multiplied with each other. And we know from my previous video, we can simplify this by adding the exponents since we're multiplying. So this x can be simplified by adding the exponents. So we have an exponent of 2, and we need to add that with our other exponent of negative 2. And we can do the same thing with our y terms. They're being multiplied with each other, so we can simplify them by adding the exponents. So we have our y, and if we add the exponents, we have a negative 4, and we need to add that with our other exponent of negative 2. And at this point, I don't want to simplify our constants just yet, so I'm just going to copy them and rewrite them exactly the same. We have a 5 squared being multiplied with a 2 with a negative 2 exponent, and this is being multiplied by our x term, which is being multiplied with our y term. So if we simplify our x term even further, we have a x, and in our exponent we have 2 plus negative 2. 2 plus negative 2 is equal to 0. And if we simplify our y term, we have y, and in our exponent position we have negative 4 plus negative 2. Negative 4 plus negative 2 is equal to negative 6. And once again, I don't want to simplify the constants just yet, so I'm just going to copy them the same. We have a 5 squared being multiplied by 2 with a negative 2 exponent, being multiplied with our x, which is being multiplied with our y. So now we have some negative exponents in our answer, which is not okay. Your final answer can never have a negative exponent. And in my previous video, I told you that a negative exponent in your numerator is a positive exponent in the denominator. So this y with a negative 6 exponent, which is in the numerator at the moment, can be rewritten as a y with a positive 6 exponent in the denominator. And we can do the same thing with our constant 2. Right now we have a 2 with a negative 2 exponent in the numerator, and we can rewrite that as a 2 with a positive 2 exponent in the denominator. And everything else stays the same. Our 5 squared, which is in the numerator, stays in the numerator, and our x with a 0 exponent, which is in the numerator, stays in the numerator. So now we just need to simplify this a little further. In our numerator, we have a 5 squared. 5 squared is equal to 25, and that is being multiplied by x with a 0 exponent. Anything with a 0 exponent is equal to 1. So this is being multiplied by 1. And in our denominator, we have a 2 squared. 2 squared is equal to 4. And that is being multiplied by y to the 6th, which can't be simplified, so it stays the same. So in our numerator, we just have 25 times 1, which is just 25. You never really need to multiply by 1, so I'll erase it. And in our denominator, we have 4y to the 6th, which can't be simplified even further. So this is our final answer, 25 over 4y to the 6th. So here we have another more complicated example. Notice in this example how we have a big fraction with an exponent on top of it. And notice also how on the inside we have fractions as exponents. So if you think you need some more practice, feel free to check out this example on my next video. If you feel like you don't need any more practice, I want to say great job for understanding the properties of exponents so well. I really hope that you are enjoying these videos, and I will see you in my next one.